Today we're going to look at synthetic division. What is synthetic division? It's just a quicker way to divide two polynomials rather than having to go through the long division. All right? Now the important part is you can only use synthetic division when the divisor is a linear factor. In other words, you can only see a plain x in the divisor. Let's take a look at an example of what I'm talking about and how we can use synthetic division. So I have this polynomial, 3x to the fourth minus 2x cubed plus 7x squared minus x plus 4, divided by this divisor of x plus 2. All right, so why do I know I'm allowed to use synthetic division? Well, this is what we call a linear factor, meaning this x's exponent is a 1, right? Moreover, I really like to have this leading coefficient to be a 1 as well. So in general, when do I say I should use synthetic division instead of long division? When I see a plain x as my divisor. Okay, so now how do I actually do this synthetic division? Well, here's what we do. Synthetic division focuses on the numbers, the coefficients and the constant in the problem, and not so much the x's. Okay? To divide this polynomial by x plus 2, here's what we do. We first take the constants the constant in the divisor, the x plus 2, and I'm just going to take the 2 out and put it in the far left corner. Oh my God, wait, look what happened. Wait a minute, how does that happen? When I take the 2 away from an x, look at it, it changes signs. Hey, just like when we did transformations, right? When you describe transformations. Ladies and gentlemen, whenever you do synthetic division instead of long division, this number will change signs as you pull it out and put it in the far left corner. Now, I put a little box around him. To the side of this number, I'm going to put all the coefficients and the constants of my polynomial. I'll start with a 3, and then a negative 2, and then a 7, and then a negative 1, and then a 4. All right? It's important, ladies and gentlemen, that every coefficient and constant is accounted for, starting with my leading term and going down 1 degree at a time until I get to my constant. Okay, to actually do the synthetic division, after I've copied this down, I now leave a space, draw a line, and this arrow means to bring this 3 down below the line. Now here's what I'm going to do. I'm going to take this 3 and I'm going to multiply it times the negative 2 that's in this box. And then I'm going to put my answer underneath the next number in the list. Well, negative 2 times 3 is negative 6. And then I'm going to take this answer and I'm going to add the negative 6 and the negative 2 together to get the next number in the line. Negative 2 plus negative 6 is negative 8. I now repeat the process. I multiply the negative 8 times negative 2. I get 16 and I write my answer there. Underneath the 7. I now add these numbers together. I get 23. Multiplying 23 times negative 2, I get negative 46. Adding negative 46 and negative 1, I get negative 47. Multiplying negative 47 and negative 2, I get positive 94. Adding 94 and 4, I get 98. We always put a little box next to that last number. This last number in the division is going to be the remainder, just like that we had when we were doing long division. So what is the answer to this when I divide two polynomials? Well, it should be another polynomial. Well, these numbers right here are what I'm going to use for my coefficients and constants of my quotient. What I'm going to do is say, well, when I divided an x to the fourth by a linear factor of x to the fourth divided by x, well, this always has to go down by 1 degree, so that goes from x to the fourth to 3x to the third minus 8x squared plus 23x, and then minus 47, plus, using this remainder, I put that back over my divisor of x plus 2. And that is the answer when I do synthetic division. Okay? Let's do another one. Let's do a polynomial such as, let's divide 2x cubed minus 7x squared minus 2x plus 7. Let's divide that by x minus 1. Okay? Again, as I take the the number out of the divisor and put it in the box, remember, you only take the 1, not the x, and you always change the sign of this number. Okay? Now to the side, I'm going to put my coefficients 2, -7, -2, and 7. Go into division, I get, bringing down the 2, 2 times 1 is 2. Subtracting, I get -5. -5 times 1 is -5. Adding, I get -7. -7 times 1 is -7. And adding, I get a 0. All right? Well, if you ever get a 0 as a remainder, all right, I created this little washing machine here. This means there's no remainder. If I knew how to spell remainder. Well, gosh, what does it mean when two numbers divide so that there's no remainder? Like, what does it mean when 6 divided by 2 is 3 with no remainder? Well, that must mean that 2 is a factor of 6. Well, similarly, what this means is x minus 1, this x minus 1 that I created, I was divided by, he must be a factor of the 2x cubed minus 7x squared plus 7, right? So let's go ahead and write this out. So when I divide, I get this new polynomial, 2x squared. And again, why is it an x squared? Because I divided an x cubed by an x. So I get 2x squared minus 5x minus 7 as my answer. Okay? And again, moreover, I can say x plus x minus 1, ladies and gentlemen, is a factor of x cubed, I'll say 2x cubed minus 7x squared minus 2x plus 7 because there's no remainder. Okie dokie, let's do this one more time, ladies and gentlemen. Let's take, let's see here, let's go x cubed minus 8, and let's divide that by x minus 2, okay? Well, again, what number would I put in the box? I put a 2 in the box, right? You always change the sign here. Now, coming out through the side of this, putting the coefficient that I'm going to start with is 1x cubed. Now, here's the important part. Ladies and gentlemen, you must represent every exponent starting at 3 and going down. How many x squareds do you see in here? I see 0 x squareds. How many plain x's do I see in here? I see 0 x's. And what's my constant or plain number? It's a -8. So now, this is the numbers I'm going to use synthetic division on. Bring down to 1, I get 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 plus 0 is 4. 4 times 2 is 8. And -8 plus 8 is 0. Oh, washing machine. What does that mean? Hey, x minus 2 is a factor of x cubed minus 8. What's my actual quotient? It's x squared plus 2x plus 4. And look how fast that is rather than doing that long division. Well,